Hey everybody, today I'm going to go over how to control converter charge pressure with Holley Efi. So, if you don't know what we're talking about, I'm going to show you a picture here. This is a transmission, and I don't know where I found this picture at. It was somewhere online. If this is somebody else's picture, I'm not trying to take credit for it or anything, just whatever. So, the torque converter's up in here, and you've got a converter charge circuit. This is the outlet, right? It comes out of here and it goes to this dump valve. This isn't the setup that I use, but this is a really good picture to show you how it works. The fluid comes in here, hits this valve, and then goes through here and drains back to the pan. So a lot of times what happens is you come out of here, you go back to your cooler, and then you come back, in through there. And then typically people will put a jet in here somewhere, in the return to slow down the flow, right, to keep the converter full. So what we're going to do is we're going to talk about how to manipulate that with a dump valve. So we're in Holley Efi software. This is build 220 on V6, and we're going to go into the Racetrans ICF. If you don't have the transmission ICF, go over here to Toolbox and then go to Add Individual Config. Scroll on down until you find transmission, give it a double click, and then at the bottom is racing. Okay, so just select that and then hit open. I'm not going to do that because we already have it. It'll bring you to this. So select your transmission type for racing and then however many speeds you have. This is a 3-speed turbo 400, so there's obviously 3 gears. So we've got dump valves and spool assist valves, converter lockup, shift output, but what we're going to focus on today is the difference between these two and then how to make this work. Spool assist valve, these are the easiest way to manipulate converter charge pressure, and you're only going to do it on the trans brake. We've got we can enable it, a minimum TPS, and then when we want it to turn off. These are great if you've got a combo that's hard to get to spool and that's all you want the dump valve to do. What we're going to focus on today is actual dump valve control in the software. So click dump valves, and we've got up to 4 options here, right? So you can have up to four dump valves. So my personal car's got 3. We no longer use this one, internal dump. That's a feed side dump. So if we look at this picture, that's inside of the transmission, and it is before it goes into the torque converter. So it makes it extremely loose. We don't use it anymore. Not really needed for my application, but there might be some people that do need it for their application. So let's get back to it. I have 2 external dumps is what I use. One has got a 140 thousandths jet, and the other one's got a 90 thousandths jet. Okay, so what that means is when my dump valves open, they can bleed off up to 140 thousandths of an orifice or 90 thousandths of an orifice back down to the pan. So obviously the larger orifice is going to bleed off more than the 90 thousandths, right? So the 140 thousandths orifice is going to always remove more pressure than the 90 thousandths, so on and so forth. If you had 160 and an 80, obviously the 160 is going to bleed off more pressure. The more pressure you bleed off, the looser the torque converter becomes. So the way this works is, I just named them so that it was easy for me to keep up with what's what. Minimum TPS for activation, that's obvious, right? You have to have at least that. And then active winch on trans brake, right? So, excuse me, if you want it to be on when it's on the trans brake, you would check here. And then we have output duration. So this is how long do we want to leave this dump valve on when we let go of the trans brake button. Okay. So here's a log. I'll show you what we're talking about here. So if we look, I've already zeroed this, so we're right there. We're at 0, right? So right up here you can see there's 0 time. That's right when you let go of the trans brake button. Let's roll on out here. In this run, we leave the first dump valve, right? So if we look right here, right here's the dump valves. They're at 100%, which means they're open. We leave the this is an old setup, but this one had a 60 thousandths jet. So, excuse me, we leave the 60 thousandths jet open for the first 1.6, right? And you can see it closes, right? It goes to zero. And then notice what converter charge pressure is doing. That's down here. We're on the trans brake. We got 36 pounds because we got them both open. When it flashes, it only flashes up to 81 pounds. And then when we close it, notice we're at 39 and we get a little spike, right? So it gets up to 46. We close this one here, all the way out here at 2.0. And this was this was a learning curve. This was kind of a mistake with this one. I closed this way too late. Like leaving this open for 2.0 was just way, way, way too long. And we don't allow any time for the converter charge circuit to recover. And then the shift happens right here. So there, pull that up. The shift is literally right there. So it never actually has a chance to recover because it hits the shift, and then we're smooth sailing going all the way out here, right? So the way this works, the more converter charge pressure you have, the tighter the converter is. So most cars, I'm going to zoom in here, most cars that spin from, most turbo cars that spin, I should say, typically either happen right here or right here, where the converter starts to come together, right? So if you notice that this RPM trace rolls and then flatlines, somewhere in this neighborhood is usually where somebody's going to spin the tires, right? Because you're pulling the engine back down, right? So the engine's accelerating coming up, and then it starts to come down, right? So it's pulling the engine down, the converter's grabbing a hold of it. This right here cushions the blow. If these dump valves were not open, the RPM trace would look a lot different. It would be a lot slower through here, okay? So this isn't a typical RPM trace for this car. This is just because we're on 235 tires. So let's look at another one on these little tiny tires to kind of give you an idea of when you change the dump valves. So if you don't know what I just did there, I open up a comparison data log, and what it does is it puts two data logs on the screen, right? We've got one here, the solid line, and then the second one here, which is the comparison. That's the second log. So the first log is here on the top, the second log is here. So now we look at this, the way this works. We redid the way we did the transmission control inside of this thing between these two passes, but you still get a decent idea. We start shutting these dump valves off earlier, right? So you see we've got the dotted line is shutting the dump valve off earlier, right? So if you compare this purple dotted line, that's, what is that one? That is the 60 thousandths jet, right? We shut that one off earlier, and then here is where we shut it off on the first log. So you can see that the spike in converter charge came back a lot sooner, right? And a lot higher. So we only held that one open for 1.2, where prior we held it open for 1.6. So at 1.2 it shuts. Then this is a question I get a lot. They say that I look at the log and the converter charge pressure takes like a tenth or so to respond. Well, yeah, because it actually has to fill the circuit. So the valve shuts, and then mechanically it actually has to fill the circuit. So we look at this, we've closed this valve at 1.2, and then it doesn't respond until roughly 1.33. So about a tenth. Then we close the second one right here at 1.4 probably. Yeah, 1.4. And we've got another jump in converter charge. And then we see that the converter charge starts to couple right before the shift, right? So exactly the way I would want it, you know? So if we're looking at the dotted line is here. This did a lot better. I believe this went like this one a 59, this one a 459, the dotted line, where this one went a 476. So it had more boost in it up top, but either way, the dump valve control softened the blow on that little mini tire and was able to get down the racetrack. So one of the big things that people miss with a converter control, right, is if you look at this, this curve, you see how it falls, right? And it pulls it down just like we were talking about earlier. Um, if we here, I'll close these so it's a little easier to see. If we look at how the converter rolls, right? Like you see how this one was nice and smooth, linear, very lazy. It was very low on power, but it was lazy. Um, you see how it comes in and then it starts to flatline. This pull down right here is more likely to knock the tires off if you're on like a traction limited surface, where this here, with an RPM trace being a little bit more linear, is less likely to knock the tires off because it's not seeing an abrupt change in the way that power is being applied. So we can pull up the G meter. This is a different video, but if you don't know what a G meter is, you probably need to buy one. Um, the G meter is down earlier, right? Because notice the charge pressure is down early, right? So converter charge is down right here, 51 versus 77. And notice the G meter is down also, 1.2 Gs versus 1.55 Gs. So it you can tell that the thing was just slower to respond. And if you look, it's even got more boost in it, right? So, um, but converter charge control is one of the things that separates the people that go down just about every other pass or every pass versus the ones that are spinning the tires all the time. So to recap, dump valves. This output duration is when we're turning it off. This is if we want it on when we're on the trans brake. We have a pedaling strategy, so if you do pedal it, you can continue the timer. This is the timer, right? Um, and then there's a couple different ways, other ways that you could turn it on and off as well, right? So if you wanted a sensor to be able to turn it on and off, or a sensor value to turn it on and off, you could. So you could do an enable trigger, and then you can set, this at, boost is, I don't know, above zero, and then deactivate at 9 psi. And then it would only work between 0 and 9 psi if that's what you wanted to do. So there's a couple different ways to set it up. You can also pulse the output. So, but I will warn everybody. A lot of people think that it's an awesome idea to PWM their dump valves, and that's fine. You can, but look at what we got here. We've got this right here. We're at 68 psi of converter charge. It takes a tenth for it to respond and jump up to 107. So pulsing it shut is not going to make that big of a difference, right? And that was the small one. Then we shut the big one here, right? And we jump from, what are we at, 98 or whatever, 100 to 116. Again, it's not a huge jump. You know what I mean? So pulsing it is what everybody seems to think that they need to do, but it's doesn't necessarily mean that you have to. So I keep it simple. I don't pulse them, but you're welcome to do that. If you wanted to pulse them, you would click pulsed output active, and then you would set your frequency. And I usually would use strategy type of time based. The way this would work is you would come in here and modify the 140 jet. And notice our time is set to 1.8 seconds because I set it a little bit longer than what we're going to be working with here. No matter what, it's going to shut at 1.4 because that's the output duration. So if you wanted to pulse shut, you would come over here to 1. Whatever, put that at 0, put the rest of these at 0, and then you could slowly start to pulse it shut, from 1.0 to 1.389. So nice and easy. And then, of course, you could do the same thing with, the other one, right? You do the same exact thing here. If you wanted this one to shut by 1.2, we can make all this 0, and then we can pulse it, like that. So hopefully that answers questions on how to use dump valves and in Holley Efi, and how to control converter charge pressure. I'm not going to tell you, what's too high, what's too low. It's all, kind of application based. But I typically like to keep them somewhere in the neighborhood of 100-ish. You know what I mean? Also, I saw a couple of questions about, what should my converter charge pressure be when it's in high gear? Again, application based. If you look at this, you may think that my converter charge pressure is all screwed up, but it's not, right? Um, it comes together really, really tight in high gear. This works exactly how I want it to work. So, um, anyway, hopefully this answered some questions. Good luck and have fun. See you.